So, hello everyone. In today's lecture, we are going to solve some more problems based on the complex number today. Okay. So let's come to the first question. First question, they said, let modulus of z is greater than 1 and smaller than 3, greater than equal to 1 and smaller than equal to 3. And argument of z lies between pi by 6 to pi by 3. Find the area bounded by the given condition. So first, we'll try to sketch the graph. Actually, which region area they are asking. So if we'll draw the graph, let me change the color. Now, first we will draw for modulus of z is greater than equal to 3, greater than equal to 1. Modulus of z is greater than equal to 1 means it represents a circle with radius 1. With radius 1 and center at origin. Now, and it is the modulus of z is greater than equal to 1 means it represents the region outside this circle. Now, next, modulus of z is smaller than equal to 3. That means it also represents a circle with radius 3. So both will be concentric circle because for both the center is origin. For both circles, center is origin. So this is another circle. This represents the area outside this circle. Represents the area outside this circle. And the second inequality, modulus of z is smaller than equal to 3, represents the area inside this big circle. So we'll get the area between these two concentric circles. Now next, they said argument of z should be between pi by 6 to pi by 3. So where is what are the complex number having argument pi by 6? The complex number we can draw with help of array. These are all the complex number having argument as pi by 6. And next, the complex number having argument as pi by 3. So these are the complex number which are having argument pi by 3. Got it? So now next, the complex number should be in between these two rays, right? And the complex number should be in between these two concentric circles. That means this region. We want the area of this complete region. How to find the area of this complete region? First, we'll find the area of the big sector. Suppose this point is A, this point is B, this point is C and D. We'll find the area of sector OAB and then we'll subtract the area of sector ODC. What is the area of sector OAB? Area of the sector OAB is theta. Theta here is 30 degree, right? The angle between these two rays is 30 degrees. So 30 degree upon 360 degree multiplied by pi r square. Pi r square means 3 square minus 30 by 360 degree multiplied by pi r square. R square, r here is 1 square. Got it? Now I'll take common. This 30 and 360 I can cancel 12 times. Here also 30 and 360 I can cancel 12 times. I can take pi by 12 common. So here I'll get 3 square which is 9 minus 1. So 8 pi by 12. Answer is 8 pi by 12. We can cancel with 4. 4 2 is 8. 4 3 is 12. So 2 pi by 3. 2 pi by 3 square units. Square units is the area, required area. Got it? Now come to next question. Next question, they said find z having least positive argument. Having least positive argument. And they've given a condition, they've given an equation that modulus of z minus 3 plus 3 iota is smaller than equal to 3. What does it represent? We have done so many problems. It represents a circle with center 3 comma minus 3. So we'll draw first. It will represent a circle with center 3 comma minus 3. So it represents a circle 3 comma minus 3 lies on the fourth quadrant, right? So here the center is 3 comma minus 3. Now next is smaller than equal to 3. That means radius is also 3 units. Radius is 3 units. Radius is 3 units. Got it? Now next, they're asking find the least positive argument. The least positive argument means I have to give a complex number whose argument is in between 0 to 360 degree. 0 to 2 pi, right? So 0 to 2 pi means from here we will check the complex number which has least positive argument is this complex number, which is lying along the y-axis, negative y-axis, and on the circle, this point. So what is the coordinate of this point? The coordinate of this point will be x coordinate will be 0, as this point is on y-axis, and it is down it is 3 units, right? So minus of 3. So the complex number having least positive argument is z is equals to 0 plus minus 3 iota, or z is equals to minus 3 iota is my answer. This is a complex number which is lying on this circle as well as having the least positive argument. Now next, z max. Z max value, sorry, modulus of z max. Now, what is the meaning of modulus of z? Modulus of z means any complex number distance from the origin. From origin, which point has the maximum? From origin, which point has the maximum distance of this on this circle? So for this, what we'll do first, we'll find the origin to center distance. Origin to center distance is under root of 3 square plus minus 3 square. So this will be 3 root 2. And this point will be at the highest distance or at the maximum distance. So this distance is 3 root 2 and this much distance is equal to radius, which is 3 units, right? So 3 root 2 plus 3 is my answer for the second question, the modulus of z max. Now we'll solve this question. This question, what they said, they've given a complex number z. Z complex number is, the real part of this complex number is 1 plus cos 2 theta plus iota times sine 2 theta. So now next, we have to find modulus of z. Modulus of z is nothing but under root of real part square plus imaginary part square. So 1 plus cos 2 theta whole square plus sine 2 theta whole square. Got it? Now we'll solve. What is cos 2 theta whole square? 1 plus cos 2 theta. 1 plus cos 2 theta is 2 cos square theta whole square plus sine 2 theta. Also I can break in terms of theta. Sine 2 theta is 2 sine theta cos theta whole square. Now next, this will be 4 cos power 4 theta. 4 cos power 4 theta plus this will be 4 sine square theta cos square theta. Now can I take, I'll take 4 cos square theta common. So if I'll take 4 cos square theta common, outside I'll get 2 cos theta mod, and inside this root I'll get cos square theta plus sine square theta. This one is 1. So here I got the answer as mod of 2 cos 2 theta. 2 cos theta. Mod of 2 cos theta. Now theta they have given is in second quadrant, right? 90 to 180 degree. So theta is in second quadrant means cos theta is negative in second quadrant. Cos theta negative means 2 cos theta is also negative. So this mod will open with negative sign. So modulus of z will be minus 2 cos theta. So this is my answer, minus 2 cos theta. Now next they have given this statement, 2 plus iota upon r is equals to, in bracket they gave one complex number, 1 plus iota square plus 4 iota multiplied by cos theta plus iota sin theta. They are asking modulus of r value. So here we'll start. First we'll take modulus both sides. So if I'll take modulus both sides, I will get 2 plus iota upon r mod is equals to mod of mod a into b. I can write as mod a into mod b, right? This is a property of mod. This property only I will use, and here I'll write 1 plus iota whole square plus 4 iota multiplied by mod of cos theta plus iota sin theta. Got it? Now next, here I'll get 2 plus iota mod of r, 2 plus iota divided by mod of r is equals to, this one if I'll expand, we will get 1 plus I square plus 2i plus 4i multiplied by mod of cos theta plus I sin theta. Now next, now we'll find modulus. So 1 and I square got cancelled. Here I have 6 iota. What is mod of 6 iota? Mod of 6 iota is 6. multiplied by mod of cos theta plus sin theta, is it will come under root of cos square theta plus sin square theta, which is also 1, is equals to, here in numerator you see modulus of 2 plus iota means under root of 2 square plus 1 square divided by mod of r. Now from here we can write this as root 5 by mod of r is equals to 6. So here from here mod of r will be root 5 upon 6. Mod of r will be root 5 upon 6. Got it? Now in this question they said find the complex number z, find the complex number z which will satisfy this equation. They have given an equation iota z cube plus z square minus z plus iota is equals to 0. Got it? So here we'll try to factorize this one. So from first two terms, can I take z square common? If I take z square common, so here I'll get iota z plus 1. From next two term, what is next two term? Next two term is minus z plus iota. Got it? As we can see that these two are not same. So in this, from the second bracket, I am going to take iota common. So try to take iota common. What I'll get? Z square iota z plus 1. Take iota common. If I'll take iota common, I'll get minus z upon iota plus 1 is equals to 0. Now from here, z square, here I'll get iota z plus 1, and from here plus iota minus z, 1 by iota is minus iota, right? So here I'll get minus iota plus 1 is equals to 0. From here z square iota z plus 1 plus iota, and here I'll get z iota plus 1. Now can I take z iota plus 1 common? So I will take z iota plus 1 common. Z iota plus 1 I will take common, and here I will get z square plus iota is equals to 0. So now either this can be 0 or this can be 0. So if this one is 0, I will get z iota plus 1 is equals to 0. So from here z is equals to minus 1 by iota, minus 1 by iota. So from here I got z is equals to iota. So one solution we got for z, which is z is equals to iota. Now next if we will solve or part means this should be 0. It means z square plus iota is equals to 0. So z square should be equal to minus of iota. Now what is the value of z? Value of z will be under root of, value of z from here will be under root of minus iota. Now how to find under root of minus iota? We'll use the method to find the square root of any complex number. Under root of minus iota I'll assume as a plus ib. Next I'll do squaring both sides, so I'll get minus iota is equals to a square minus b square, as I square is minus 1, right? That's why minus 1 will come here. Again plus 2 iota ab. Got it? From here if we'll compare a square minus b square, a square minus b square will be 0, and 2ab, the value of 2ab is minus 1. So a square plus b square, or a into b, from here I can write a into b is equals to minus 1 by 2. A into b is negative. Negative means both a and b are of different sign. Now next, from here if I'll send b square to that side, I'll get a square is equals to b square. If I'll take under root both sides, we'll get a is equals to plus or minus. Got it? A can't be equal to plus b. If a is equals to plus b means both are of same sign. Here I got product as negative. That means guaranteed both are of opposite sign. So a is equals to minus b is correct one. Now next, we'll try to solve these two equations to get the value of a and b. If we will solve these two equations, we'll keep the value of a from this equation to this equation. So we'll write a is nothing but minus b. So minus b multiplied by b is equals to minus 1 by 2. Minus minus got cancelled. B square is 1 by 2, or b is equals to plus or minus 1 by root 2. And what is a? A is nothing but minus of b. So when b is plus 1 by root 2, at that time my a value will be minus 1 by root 2. Understood? And when b is minus 1 by root 2, my a value at that time will be plus 1 by root 2. Got it? So the complex number z, the required complex number z, first solution we got this one, right? First solution we got this one, and next solution we got after finding the value of a and b. So the z value finally we will get, the z value we will get is, first value of z is iota, or The next value of z is when a is plus 1 by root 2, b is minus 1 by root 2. Got it? Now next, or one more value of z, when a is minus 1 by root 2, b that time is, both are of opposite sign, right? B at that time is 1 by root 2. So either this one or this one or this one. There are three complex numbers which will satisfy this equation. Got it? Now next, we'll try to solve this question. What they've given in question? They've given a complex number v, right? V is a complex number and they said v is purely imaginary. Then we have to find the modulus of z. So if any complex number is purely imaginary, then if z plus modulus of z, in that case, if any complex number is purely imaginary, in that case z plus modulus of z is 0. Got it? Because there is no real part, right? And imaginary part will get cancelled. It is an imaginary number, purely imaginary number, and plus the conjugate of purely imaginary numbers. So this will come with negative sign, so both will get cancelled. Y and minus y will get cancelled. So here v they gave, v is what? Purely imaginary. So here we'll use this equation only. If v is purely imaginary, that means v plus v bar is equals to 0. This you can note down that this is the condition for purely imaginary complex numbers. Got it? So what is v? V is z minus 1 upon z plus 1 plus mod of z minus 1 by mod of z, conjugate of z minus 1 divided by conjugate of z plus 1 is equals to 0. Now we'll take LCM. If we will take LCM, we will get here z plus 1 multiplied by mod of z plus 1 in the denominator, and in numerator we will get z minus 1 multiplied by conjugate of z plus 1 plus conjugate of z minus 1 multiplied by z plus 1 is equals to 0. Got it? So now we'll multiply. If we'll multiply, we will get z multiplied by mod conjugate of z, z multiplied by conjugate of z, and again z multiplied by 1 is z plus minus 1 multiplied by conjugate of z is minus conjugate of z minus 1. Minus 1 multiplied by plus 1 is minus 1. Plus from here same conjugate of z multiplied by z will come first term, plus conjugate of z into 1 is the second term, minus z minus 1 divided by z bar plus z bar plus 1 is equals to 0. Got it? Now we'll send this to that side, so it will be 0. From here we'll see if anything is getting cancelled. Here minus modulus of z, here plus minus conjugate of z, and here plus conjugate of z is there. Here's plus z and here minus z is there, so this both will get cancelled, and this will go to that side, multiplied by 0 will get cancelled. So here we have multiplied by 0 is equals to 0. So from here we have z into z bar, 2 times z into z bar, 1 here and 1 here, minus 2 is equals to 0. So from here we got z into z bar is equals to 1. What is z into z bar? Z into z bar is nothing but modulus of z square is equals to 1. Means modulus of z is equals to plus or minus 1. We have seen in the properties of modulus that modulus can never be negative. So that's why here modulus of z will come plus 1. Minus 1 we will reject. This is the answer for this question. Thank you.